Welcome to Aha's channel. Here's the fourth problem from 2026 Hypatia's math contest. The first question is looking for case value. With this expression including the x and the y first, and moving the x and the y to one side, and the rest to the other. And then, by doing some algebraic manipulation, we obtain our answer is 2m plus 1. For the other side, x squared y squared minus z squared is the same thing, with this expression including z and y, and then putting the y and z on one side and the rest on the other side. Then, by opening brackets, we obtain our answer for y squared minus z squared, 2m plus 3. Then we compare two answers, 2m plus 3 minus 2m plus 1, which is equal to y squared minus z squared minus x squared minus y squared, and it is equal to k, and our answer for k is 2, and this is our first question's answer, 2. The second question is a little bit tricky. First of all, we do y squared minus z squared, 12, and then use the formula first number plus the last number times number of a sequence over 2 to get our sum for y squared minus z squared with a given condition 2y minus 1 minus 2 times p minus 1 bracket plus 2y minus 1 bracket times p over 2. After simplify, I get the first important thing of 2y minus p times p, which is sum of y squared minus z squared. Do the same thing for the x squared minus y squared, first number plus the last number, 2x minus 1 minus 2 bracket p, 2 minus 1 bracket, plus our last number 2x minus 1 bracket times q, number of consecutive odd number integer over 2, and we get the answer similarly 2x minus q times q. Next step, we're going to introduce something really critical and important. We write n squared equal to 1 plus 2 plus 3 plus 5, the consecutive odd integer, to plus the last number n minus 1 brackets times 2 plus the first number plus 1. After simplify, we can get our last term number as 2n minus 1. Right in the general term formula, we can get 1 plus 2n minus 1 brackets over 2 times n, and then simplify again, we get n squared. So use this property, we can get, we write y squared equal to 1 plus 2y minus 1 brackets over 2 times y. Same thing for z squared, we can write z squared equal 1 plus 2z minus 1 over 2 times z. We know y is bigger than z and m is bigger than 0. And in the first question, we see y squared minus z squared equal positive integer number. So this shows y is bigger than z. Then we are going to list a series of y squared and z squared to compare. So we do y squared equal y 1 plus 3 plus 5 plus dot 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 till bracket z 2z minus 1 bracket plus 2z plus 1 bracket, then dot 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 to the biggest number 2y minus 1. Then we do the same thing for z squared. So 1 plus 3 plus 5 plus dot 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 to the last number of z squared 2z minus 1 bracket. We can see the differences is really simple to easy to see. So y squared minus z squared is equal to 2z plus 1 bracket plus 2y minus 1 bracket over 2 times p. Then we do z 2z plus 2y bracket over 2 times p equal to z plus y bracket times p. And this is equal to the answer we get previously, where 2y minus p brackets times p. So right now we can do some algebra to get the y, p, and z. So since p is bigger than 0, we can simplify p by dividing the p on each side. And then we do z plus y equal to 2y minus p. Move the y to the other side, we get z equal to y minus p. Then we do the same thing on the x squared minus y squared. Here I neglect the process, but the general idea is the same. Based on all conditions we know, such as x squared minus y squared plus 2 is equal to y squared minus z squared, x equal y plus q, y squared minus z squared is equal to 2yp minus p squared, etc. We get our answer y equal q squared plus p squared plus 2 over 2 times p minus q. We notice in this situation p minus q cannot be 0, since if p minus q equals 0, the second line of the equation will not be true, since the smallest integer p squared and q squared is 0, and this will lead to 0 equal to 1p minus q equals 0, and this is impossible. So we get our answer for the question 2. The third question, based on what we know, we can see y is positive integer, so p squared plus q squared plus 2 has to be 2k, an even number. P squared plus q squared equal 2k minus 2, or 2k prime. P and q has to be both even or both odd. And in this case, p minus q for sure is 2k, another even number. And we know a squared plus b squared plus 2 for sure is bigger than 0 in this case. P minus q has to be bigger than 0 if we want to let y be positive. So this means p minus q is 2k. K exists in z plus. So based on this, we assume k is equal to 1. So p minus q equal 2 and p equal q plus 2. Then we substitute the value into y's expression in the term of p and q, and we can get our answer q squared plus 4q plus 4 plus q squared plus 2 over 4 is equal to q squared plus 2q plus 3 over 2. Again, as we can see, q squared plus 2q plus 3 have to be an even number in order to let y be a positive integer. So q squared plus 2q have to be an odd number in order to let odd number plus odd number equal 2k, an even number. As a result, q and p is our odd number. While q equal 1, we get s is equal to 25, but z is equal to 0, contradict with our condition. When q equal 3, it works, and we get our answer is 1105. For any q that is an odd integer bigger than 1, you can find a Thousand number corresponding to it.